So hello, welcome to this Sharcnet webinar. Today I'll be speaking on the fundamentals of working at the command line at Sharcnet. So some topics we're going to cover today. First, we'll start off with some basic Unix concepts so that you can be familiarized with the underlying systems that are operated at Sharcnet. And we'll go into some basic bash command line behavior, what the experience is when you first log in and are presented with a command prompt. We'll then go on to cover file systems and file permissions. This is a fairly lengthy topic, but we're just going to skim over the most essential points of it. After that, we'll go into managing files, options for doing text editing on the systems, followed by command pipes and redirection, some facilities at the command line you can use to conveniently construct more complicated operations. And finally, we will cover shell variables, shell initialization, and the writing of shell scripts. So to get started, first thing you'll want to know about the command line is, what does it actually consist of? What's actually running behind it? So at Sharcnet and most high-performance computing facilities, as well as most web servers and whatnot, they are all running an operating system called Unix, or some variant of it. So you can see on this table on the right-hand side here, there's a Unix timeline. The first version of Unix was written, in the very early 70s by Ken Thompson and Dennis Ritchie at Bell Labs. It then went on to fragment into many different projects that all provide a basic operating system that operates much like Unix. So you can think of Unix as a similar operating system to, say, Microsoft DOS, Windows, for example. So most of these Unix-based operating systems, including Linux, have a GUI interface, so a graphical user interface. But primarily and originally, they all started off as purely a command line interface. One of the nice things about the command line is that you can construct complex and abstract interactions with the underlying system far easier than if you were using a mouse pointer and working through a GUI. So the basic process for when you log in, when you first log into one of the Sharcnet systems, the system will start what's called a shell process for you. So the shell acts as a command interpreter. It allows you to interact with the underlying operating system through a series of commands. At Sharcnet, and I think in general on most HPC systems in Compute Canada, the default command interpreter shell is called the bash shell, and it stands for the born again shell. So we're going to focus primarily on the features of it, although you are free to explore and look into other types of shells that are available on the systems. So some basic Unix concepts. If you're coming from the Windows world, these ideas might not be familiar to you, or they might be put in a different way. So, the basic ideas behind Unix. The first is the file, so it's kind of the atomic feature of the Unix operating system. So basically, a file is any data. It's stored in a standard format, and depending on how it's acted upon by the operating system, it may behave different ways. One thing to note is that in Unix, basically everything is considered to be a file. A program is a file that you can actually execute or run. The operating system can run through it, process its commands, and then take actions to modify, create, delete, and whatnot, other files. A process is a program that's actually being run by the system at a given time. So for example, if you submit a job to Sharcnet, once it starts running on the compute nodes, it will execute your program file, and then while it's executing that, it will have put it into memory, and it will be treating it as a process. Within Unix, it's a shared operating system, so all the resources within it are shared, and they're allocated according to the operating system's configuration and whatnot. So all the files within the operating system have a sense of ownership, so they can be owned by a particular user on the system, but they can also be owned by a group of people. So that includes programs and processes as well. Then finally, one of the last main concept is the idea of a hierarchical directory structure. So the way the files are laid out on the operating system is such that they're put into a hierarchical directory. You may consider, in the Windows parlance, you'd call these folders, for example. So the directories are set up such that they have a parent. So you can see here, you read from left to right. So the sim1 file sits in this $user directory. So it's the parent directory of that file. $user directory is a child of the home directory. So it's the parent of $user. In this way, every file exists within this tree structure. The base of this hierarchy is the root directory. So in Unix, it's referred to as the root. It's just a / symbol. So it's important to understand how this directory structure works. I'll go into this in a bit. But essentially, when you're using a Unix-based system, it's crucial that you understand how to manage your files and the processes that you're running to make sure that you're making efficient use of the system and to make sure that you can get your results as fast as possible. So first things first, the experience when you first log in and get started at the command line. And perhaps this might be the most important slide in this whole presentation because there's some tips here that many people will never realize until they've been on the system for quite some time. So, of course, the first thing you do for Sharcnet systems and for most Unix-based systems is use Secure Shell SSH to log into the system. When you first log in, you'll see the message of the day output, and then you're left at a command prompt. So you'll just see your username, your directory, $, and then it'll be a flashing prompt there, and that's where you're starting off. So one thing to keep in mind is that every time you execute a command, you're actually starting one or more processes on the operating system, which then run to completion, and they will either produce output in your terminal, in the window that you've connected with, or else you can also have output in files. So as you're working along, one thing that you can do, which may help when you're coming back to work that you've done in the past, is use the history command. So this will allow you to look and see which commands you've run in the past. That can be very useful, especially if you can't remember where you put a file. If you were working on the system yesterday, you can scroll back through your history to see, where you may have put it. If you do not like typing lots and you're running a lot of the same types of commands, you can scroll through your previous commands using the up and down arrow keys. That's very handy as well. There's no point typing in the same thing over and over if you can just press up and then run that command again, or maybe just make a small modification. Probably the most important tip is that you can complete commands and arguments using the tab key. So what you can do is type in part of a command, press tab, and then the system will either complete it immediately for you, or it'll show you a list of possibilities that can possibly complete that command. This also works for arguments to commands. So if you're typing in a command and then you want to specify a file to that command, you can type in the beginning of the file, and as long as that beginning part is unique, pressing tab will complete it for you. So that can save you a lot of key presses and allow you to work very quickly. Depending on the terminal you connect with, like the software using your SSH client and whatnot, you should be able to go to the start of a command line by pressing Control and then A, or the end with Control and E. You can also cut the text from where the cursor is to the end of the line with Control K. So this allows you, if you're pressing up and down, to go back to commands. Say you want to change something at the start, you can just press up, Control A, go back, change it, and so forth. Then finally, once you're done running all your commands, you can just type the exit command, and then that will close down your session and log you out of the system. One trick that is useful to know is that if your terminal's hung and you're not getting anything done, you can often disconnect via SSH in a graceful fashion so that it doesn't leave things running by pressing the tilde key in the top left-hand corner of your keyboard followed by period. Sometimes it doesn't catch, so you may need to hit enter repeatedly and then try hitting tilde period again. But at least that in that case, it will try to shut down everything you have running instead of leaving it hanging around. All right, so those are just some quick tips. Now we'll start to get more into the basic structure of running commands. So, as I mentioned, to run a command, you simply type in its name, you hit the enter key, and then the system will go off and execute that command. One aspect of this is that the command has to be in your path. So this is an environment variable. We'll get into that later. And the command has to have executable permissions. If the operating system can't find the command, or if the command isn't an executable file, then it won't execute it for you. So the general syntax of a command is the following. You can see here's your prompt, followed by the name of the command. The command itself may have one or more options that change the behavior of the command, followed by arguments to each of these options, if necessary, and then finally, actual command arguments. So we'll step through this. So the command, this could be any number of Unix commands that are available to you or utilities. Some commands are provided as part of the operating system. Some are provided as built-in shell commands. You can also have commands which are program files that you've created or uploaded yourself. Options change the behavior of the basic command. So if you run the ls command, you'll get an output of the files in a directory. If you add -l, the -l option, then it will print a long listing of the files in your directory, showing you further details. One thing to note is that the command syntax is in uniform. Some commands require that options are preceded by a hyphen. Some allow you to specify options without a hyphen, so the ordering of the options in the command is important. Options themselves can have arguments, so they will change the behavior of the option. So if you have, for example, the tail command prints out the last few lines in a file. So we can specify how many lines we want to print out with a -c option. So if I'd only like to print out the last 5 lines of file 1, I can do -c5. If I'd like to print out the last 15, I can do -c15. And you can see that file 1 is a command argument being passed to tail, whereas -c is an option and 5 or 15 is the options argument. And as I mentioned, the command argument is usually what's affected by the command. So, you're either sending the files to the command or perhaps output of another command, which I'll show you how to do in a bit. So here's a rundown of the most basic shell commands. These are common for most shells. Definitely recommend that you familiarize yourself with each of these commands. So the first one is definitely the most important one of all. It's the man command. So it stands for manual page. So if you need to find out information about a particular command, you can just run man followed by the name of the command. And then it will display you in the terminal usage instructions, information about how the command behaves, and places to go find further information. Fortunately, I don't have enough time to go through this in detail, but I'd recommend that you try this out yourselves. Go look at the man page for different commands and see, the listing of all the options and how the syntax of the command is supposed to operate. There are a number of commands for figuring out who you are, what day it is, and whatnot. So who am I will show you your username. Host name will show you which computer you are on, and date will show you the day and time. You can navigate through the directory structure. So CD will allow you to change directories, and PWD will show you which directory you're currently in. This will also be shown in your prompt. You can manipulate files and directories. So you can copy a file with CP. You can move files from one directory to another, possibly changing their name with the MV command. You can remove files with RM. However, you can't remove directories with RM. You have to use the rmdir command to remove a single directory. There are flags that or switches or options that will change the behavior of RM to allow you to remove subdirectories. But for now, we'll just leave it at that. You can also make new directories with mkdir, make directory. You can list files in their properties using the ls command. That's the primary way. You can also look at file properties with the file command. This isn't as important as ls. You can display the contents of files using a number of commands. Cat will just echo out or copy out the contents of a file to the terminal. You should only do this with ASCII files. If you try to do this with a program executable, often it will print out binary junk and may leave your terminal in a very corrupted state. So try to make sure that you check the file maybe with file first to make sure it's ASCII before running any of these display commands. You can print out tail. That will show you the last lines in a file. You can even specify it so that as a file is updated, it will display that to the screen. Head will show you the start of a file up to a certain number of lines. You can use the more command to scroll through a file, a text file. If you just do cat, it'll print the whole thing out. If you use more, it will just show you one screen and then ask you to prompt it to display the next screen. An even more powerful command is less, actually. It'll allow you to scroll up and down through a file. And finally, WC is the word count command. So if you want to count up the number of words, lines, or characters in a file, you can use the word count command to do that. And then you can investigate your running programs using the PS command. That will show you a list of processes, and top, which has an interactive frame that sits in your terminal and shows you all the running processes. So that's just an overview of the basic commands that you should be familiar with at the command line. So we'll go into the file system structure next. So as I'd mentioned, in Unix-based systems, the root of the file system hierarchy is this /root. So it contains subdirectories which may contain further subdirectories and whatnot. Contrary to the way you'd expect things to be in a Windows-based system where you have different drive letters and they're not connected, in Unix, all of the drives are mounted within this hierarchy. So for example, when you first log in, you'll be in your home directory, so /home/$user, which is just your username. This is actually a different network drive than the file system that holds the other subdirectories of /. So you can see that there's your home directory, your work directory, your scratch directory, and whatnot, all exist within this single namespace. One tip that you may have seen and may not have been aware of is that you can refer to some of these directories by shortcuts. So for example, your home directory, you can refer to it as tilde, that key in the top left-hand corner of the keyboard, followed by a /. So if you want to look in your files in home, if you're in a different directory, you can just do ls:/. Another useful tip is that if you just run the cd command without any arguments, it will always take you back to your home directory. So if you're lost and you just want to go back to where you started, you can type cd. An important concept involved with the file system hierarchy is the idea of the path. So path just describes the location of a particular file or directory within the hierarchy. So there's two ways you can refer to this path, either as an absolute path or a relative path. An absolute path, you start at the root, the first /, and then you specify every subdirectory until you get to the output or to the file in question or the directory in question. So that's an absolute path. It refers to the full location. Contrary to that, there's the relative path. So it depends on which directory you're presently in within the file system. So you can run pwd. That command will show you which directory you're actually in. And then you can construct a path relative to that location to where the file is. So for example, if you're in home user and you want to construct a relative path to this output file, it would just be the subdirectory simulation1 followed by the name of the file. Some useful shortcuts for navigation and for specifying locations of files. For the current directory, you can use a single period. And for the parent directory, you can use 2 periods. So let's say if you're in home user simulation1 and you want to go back to home user, you could just type cd ... and that will take you to the parent directory. And if you want to run a file in a subdirectory, for example, but you don't want to specify the absolute path, you can just type period, and that will fill in with your present working directory, followed by the subdirectory and the name of the program. Note that if the program is not in your path variable, your path environment variable, then it won't find it otherwise. So you either need to specify the absolute path or a proper relative path to it. All right, so we'll step back a bit and look at the structure of files in the Unix file system, because this has to bear on the way permissions are handled. So within the Unix file system, again, it's a bit different than in the Windows world, for example. So file names can have up to 255 characters. They can include non-standard characters, so you can have things like underscores, spaces, other things that may be difficult to deal with. And another important point is that in Unix, the file name extensions don't really matter to command line programs, so they don't recognize files based on the extensions. Lots of commands will actually look in the contents of the file to figure out what it is. And of course, there are other programs which may treat files with extensions differently, perhaps, but for most command line programs, they don't. If there are non-standard characters in a file name, you may have to escape out with a backslash in front of them so that they're treated as part of the file name, or you may need to put the file name in quotes. That way you can actually act on files with non-standard characters. An important note about files is that any file that starts with a dot is hidden. So if you do a regular ls in a directory and there's a file there named .test, you won't see it show up. If you want to see all files, including hidden files, you have to specify, for example, to ls the -a flag to list them all. So as I was mentioning, files have a set of attributes associated with them that are stored, in the structure of the file system itself and in the file itself. You can see a long listing of these to get the pertinent values by running ls-l. So for each file that you run each file in the directory where you run ls-l, for example, you'll get a record like the following. And so the meaning of this output for a simple directory is as follows, for example. The first field here, 1, is the file type and the permissions. So in most cases, you don't need to know about these other file types. The important ones are regular files with just a dash, or directory files, which are directories. The permissions we'll get into more detail in a couple slides. Basically, this sets who is allowed to act on the file, whether it be to read the file, write to it, or execute it. There are also some more complicated behaviors you can specify through the permissions, which I'm not going to get into, but you could read up on that change the behavior of files and directories. Following the file type and permissions, there's a field for the hard link count. This isn't usually that important, for most purposes. You can have multiple files that actually map back to the same data, and so this tells you how many of those there are. The next field is important. It shows you the owner of the file. So it'll show you the username of the person who owns the file, or possibly their user ID. The next field shows you the group that owns the file, or possibly their group ID. So those are the two entities which can own a particular file. Following that, one of the most useful fields is the size of the file. This will be in bytes normally. You can add flags to ls to change it, to show it in human readable formats, for example. Following that, you'll see the date and time that the file was last modified. So, if you go and read a file, it won't modify it. That date won't change. If you change a letter in the file, then that date will be updated. And then finally, the last field is the name of the file. So with the ls-l command, you can get most of the important information, when you're just using the system quickly. So I'll step back and talk a bit about users and groups on the Unix systems. So each user on the system is identified by a unique username. It's actually stored as what we call an environment variable within the shell, $user. And it's associated with a numeric identifier, which we call a UID. So at Sharcnet, this is just your Sharcnet username, the one that you log into the portal with and the one that you log into the systems with. If you type ID followed by your username, you can see what your UID is. And on a Unix-based system, each user can belong to one or more user groups. So in the same way that a user has a unique identifier, groups do as well. So one thing to notice that at Sharcnet, each sponsor has their own group for themselves and their group members. And that we have other groups that exist. So for example, to access commercial software, there are institutional groups and whatnot. So you can be part of one or more groups. You can use the ID command, ID followed by your username, to see which groups you are part of and your user IDs and your GIDs. In practice, you don't really need to specify these values often though, other than just logging in or possibly changing file ownerships. You can often change your ownership of your files for the group. So you can change a file from one group to another, but you can't change the ownership. Only the administrator account or the super user, root user can do so. You can change specific file permissions with read, write, execute. These different permissions using the chmod command. So I'll just go forward and show you how this the permissions are laid out. So security on a Unix-based system is it's based on three basic actions you can take on files or directories. We refer to them as read, write, and execute. They're listed in triplets, so you can see for each file from that ls output, there's a section for owner, the first three, the middle is for the group, and the last three is for other. The meaning of the permissions depends on the file type. So for regular files, read just means that you can actually open the file and look at the contents. Write means that you can modify the file. And X means that you can execute the file. For a directory, it's a bit different. Read just means that you can list the files in that directory, with ls for example. Write means that you can actually create new files in the directory. And execute means that you can actually enter the directory. So you can CD into it and make it your present working directory. So for example, looking at the past example I'd shown, there's a file here called testdir, which is a directory. You can see D here. And it has read, write, and execute permissions for the owner. So the owner can do anything in the directory. The group only has read and execute permissions. So just R and X are specified. Dash means that that permission isn't there. So that means that the group can only look at the files in the directory and CD into it. They can actually create new files there. And you can see that for other people, they also have the same permissions. So in this way, you can set up permissions based on whether or not you want other people to see your files, just people in your group, or other people on the system. I'll go through this real quick. So the default file permissions applied to a file are based on this mask value. It's called a umask. You can set this so that when new files or directories are created, they start off with a particular set of permissions. You can specify these permissions either symbolically or as octal values. Since there's only three values here, read, write, execute, you can treat it as an octal number in binary format. So you can see that if all three are set, it's a 7. If none are set, it's a 0. And then if just R and X, that's 4 plus 1 is 5. You can also use symbolic notation. Most people will find this easier to read. So you can specify user with U, and then you can add permissions plus read, write, execute, other, read and execute. So for another example here that includes groups, you can see I've added the group permissions here. In principle, you don't need to modify your umask. I'll show you on the next slide what happens when you create a new file in terms of permissions on Sharcnet, but won't get into that too far unless I'd recommend if you are curious, you can read up on it on your own. If you want to change a file or directory's permissions, the way you do so is with this chmod command. So you can see here I've listed a file in a directory, T1, and it has read, write, and read permissions for the three different groups. If I want, I can change this file so that everyone will get execute permissions, and other people will also be able to write to it. So I do chmod followed by the permissions I'd like to set on the file, and then the file name. Now when I look at it, you can see that all the permissions variables are set. If you want to remove permissions, you would just use a minus instead of a plus here. So here's some examples of different file and directory permissions. Fortunately, it looks like it was cut off when I transferred it to PDF, but you can see for the first one, this is the default file permissions at Sharcnet. So if you just create a new file, you don't do anything to it, you will be able to read and write to it. Your group will be able to read and write to it, but nobody else will. Likewise for a directory, if you create a new directory at Sharcnet, you will be able to have full permissions to it. Your group will have full permissions to it, but other people will only be allowed to look at the file in it and to CD into it. They won't be allowed to create new files or directories within it. You can change these, so if you want to have a file that's executable by absolutely anyone, you set all of the execution or all of the permission variables to execute. If you only want to make a public executable, for example, you could change it so that only everyone else has read, write, execute. If you want to make a directory that nobody can access except the super user, then you would remove all the permissions. If you want an executable that only you can run, then you would just set the permissions for yourself and leave the permissions empty for everyone else. And likewise, if you want to have a directory that only you can see within, you'd set the permissions so that only the user triplet is specified and the group and other are not. All right, access control lists. This is a smart way to share files. So if you think about the way that the file permissions are set up, they don't let you specify permissions for just one person that is in your group, for example, or for another group other than your own, or for somebody else, but not everybody. So the way you can do this is through this access control lists. You can see what the list is for a particular file with this get file access control list command, get FACL. So you can see here for this directory, if I run it, when it prints out the file, it will remove the leading slash. So for our example, Beaker's work directory. It shows you the file name, shows you who owns the file, so Beaker owns it, and the Beaker group owns it as well. So there could be a group that has the same name as your username. It then shows you the permissions, much like the ls-l command. So you can see user has read, write, execute, group has read and execute, and other just has execute. If you want, you can add permissions for somebody else using the set FACL command. So for example, if we want to add read and execute permissions to this work directory for, say, another user named Bunsen, who isn't in the group, you can do so with set FACL -m for modify, followed by user. If you want a group, I believe you put a G here instead. Then the user's name, followed by the permissions you'd like that user to have. So it could be readx, rx, rwx, for example, followed by the file or the directory that you want to set it on. So now if we do that command and we look at the file access control list on this file again, you can see that it's added an entry for user Bunsen, and it's specified that they should have read and execute permissions only. So that's just a nifty trick to get past the basic chmod command. All right, so I'll go into managing files. As I mentioned, you can list the files within a directory using the ls command. One important feature in the shell is that there are meta characters that behave different ways depending on the context. One of the most important ones is the wildcard, the star. This allows you to do matching. So for example, if I want to find all the files in a directory named something.txt, I can do ls star-txt. So there's a lot of other different meta characters you can use that are very useful. If you're really keen, I'd recommend looking up regular expressions and learning a bit more about how they work, because they figure into many different commands. For listing files, a useful set of options is the flags -l-a-r-t-h. This will allow you to display all the files in a directory with long information. It will also sort them from the oldest to the newest file and present the results in a readable format. So instead of bytes, it will be gigabytes or kilobytes or megabytes. You can see how much space is in use on different file systems with df-h. So for example, if you want to see how much room is free in the scratch directory on one of the clusters, you can run that command and look for the scratch entry. You can see how much space is used in a particular folder using the du-h command. That will show you a listing of each file and subdirectory and how much space they're using. If you want to just see, your total usage at Sharcnet, you can run the quota command. A couple of useful utilities. One is the DOS to Unix utility. If you're copying a text file from Windows to a Unix-based system, it won't properly translate carriage returns. So it won't read it in properly when you try to specify it for another program. So you may need to run this DOS to Unix command. You can see the basic syntax is here. So you just specify the file you created on Windows, -n followed by the Windows file, followed by the file you'd like to rename it to on Linux. And then it will actually do the conversion, and the file should work properly in the Unix environment. Another useful command for managing files is the find command. You can search within file trees for particular file types, files of names, files within a certain date span, even files based on their contents. I have another slide here that kind of goes through it in detail. I think I'm going to skip past this since I'm running a bit short on time. But I'd recommend that you come back and take a look at this, or at least read the find man page to learn more about how this command works, because it is very powerful and will allow you to quickly find files that would take you a lot of time to search for if you do have a lot of files. Another important file management command is tar. So tar is just a command that allows you to archive files or pack them up into a single file. You can automatically compress your data using the tar command. This is very useful for minimizing your disk space. So if you have a lot of ASCII text files, you can mathematically compress those into a much smaller binary file using different compression algorithms. So we strongly encourage the use of tar, especially for data that you're not going to touch for a while. Say you've done your simulations, you should just tar up all the output, save it in one file, and then that makes it easy to move around and keep track of. So the way to create an archive with tar, using for example bzip2 compression and with verbose output that tells you what it's doing, is by this command right here. So tar, the first flag, C, is to create an archive. V is for verbose output. J is to use this bzip2 compression. And then F specifies the output tar file archive name. So you can see here I've specified it to be tar file output.tar.bz2. This just makes it clear what kind of archive it is. You can run file on a tar archive to see what kind it is as well. And then after that, you specify the files or directories you want to pack into this single file. If you want to unpack the file, it's basically the exact same command, except instead of C, you use a -x to start off the flags, and then it will expand everything that you've put in here back into the regular files for you. There are many switches available to control the behavior of tar. It's one popular one. Instead of bzip2, lots of people just use the gzip compression with -z instead of a J. So you may see that used quite often. And often when you get source files or data sets in the Unix environment, they will be archived using the tar command. So you need to know how to unpack them. Moving on, if you're new to the command line and you want to work on your text files in the environment, you need to pick a text editor that you can use. There's quite a few that exist. I'm not going to get into which one is the best one for you. Everyone is very opinionated about this. Just three of the most common ones. The first is Vim. This is a very minimalist editor, so it doesn't have a lot of bells and whistles. It's strictly for text editing. It's modal, so it's a bit tricky. You switch between an editor mode where you do editing commands and whatnot to a mode where you're strictly entering in text. It's really fast. You can do a lot of really complicated things very quickly with very few key presses, but it's very arcane, so it's very tricky. A lot of people dislike it because of that. Its main competitor, I guess, is Emacs. Emacs is like everything but the kitchen sink editor. So it has a lot of different extensions. It's very fully featured and very capable. So there's a lot of functionality there. But you may find that it's not you can't work as quickly as within Vim, for example. Finally, probably the one that we recommend the most to new users is Nano. It has Emacs-like controls, and it's pretty much what you see is what you get. So you can just go in, start typing, and then at the bottom of it, there's a menu that shows you, which commands you can use to save the file at a certain name or what have you. So if you're just starting off, we'd recommend using the Nano editor. One nice thing is that you can cut and paste with the mouse in all of these. Which is very useful if you want to copy code from your web browser or whatnot. It's pretty easy to do. I just recommend trying them out. If you don't take to any of these and you're still you don't want to actually get into working at the command line in text files, you can always log into one of the visualization systems and then just use gedit or one of the GUI text editors there, save your files, and they will work the exact same way. So I'll get into a bit of command shell syntax and the ability to do more expressive commands. So one of the most convenient features in Unix-based systems is the command pipe. So this allows you to string the output from one command to be the input for another command. And in this way, you can set up a long chain of commands to do a very complicated task just in one line that you can just hit enter and it'll execute. In addition to pipes, you can also redirect the output from your commands that would normally appear in your terminal after you execute the command to store that inside of a file. So if you use a single write caret, it will overwrite whatever file follows it, and all the output from your command will appear in that file. If you use two carets, it will append the output from your command to the bottom of that file if it already exists. So a quick example of how this would work is, say I want to count all the files in a directory and then store that number in a file. So, maybe file count, right? So the way you can do this is you can run ls-1, which will cause ls to print a single file name per line. And then I'll do star so that I get a listing of all the files in the directory using the wildcard. I can then take that list that has one file per line and send that output to the wc command, the word count command, using the command pipe. If I specify -l to wc, it will count up how many lines are in a file. So in this way, I'm counting every single file in that directory. WC will just output a number, so if there's 10 files there, it will just return 10. Instead of printing it to the screen, if I want to save that to a file, I can redirect the output with a single write caret to this file here. And now if I look inside number of files in a directory, it will list the number of files there. It will list the output from the WC command. So in this way, you can string together many different commands to do very complicated things. And there's a lot of other commands that you can use that do text filtering that will enable you to do very complicated things. So one command that's extremely useful is the grep command. Unfortunately, I don't have time to go through how it works in detail, but you can use grep, G-R-E-P, to filter out text based on patterns, and then you can use output from commands with grep to isolate the characteristics you're looking for, or to do analytics on your files very quickly. Another feature of the shell that you should be aware of is environment variables. So you can store values in an environment variable at the command line that exists just like in a programming language. Many of these exist when you log in. So $user shows your username, $home shows your home directory, $PUWD shows your present working directory, and for example, this path, which I mentioned before, shows a list of the directories that are colon separated, where the shell will look for programs to run. So if you type in program 32, it will go through each of those directories and try to find program 32 to run it. The $sign is what expands the value of a variable. So echo just repeats whatever follows it. If you do echo and just regular text, it will just print it out on the next line. But if you do echo followed by a variable name preceded by the $sign, it will print that out. So for example, here, Beaker wants to see where it will look for programs in his path. So if he executes that, you can see there's /bin followed by a colon and then /userbin. So those are the only places where the shell will look for programs. If you want, you can change the variable to look in other places. So you do that using the export command. It allows you to set new variables or modify existing ones. So for example, looking back at this path variable, I can export a new variable, path, which will be the existing one. Notice that when you do export, you don't specify the $sign for the name of the variable you're setting. I can set path to be equal to my home variable followed by /bin, and then separate that with a colon, and then the pre-existing path. So you can see what happens is this expands when I echo it. It expands to be home Beaker, which is my home variable, followed by /bin, then a colon, followed by the pre-existing path, which was /bin :/userbin. So in this way, you can set new variables, change variables. It can be very useful to set up variables for common strings that you're using all the time. So if you want to, CD to your special simulation directory that's 30 directories deep, in your work directory, you can just set a variable for that and then CD to that variable instead. Another related feature that's very useful in the shell is the idea of a command alias. So an alias lets you build new commands with pre-existing ones. So if, for example, I mentioned that ls has a very useful set of switches for displaying all the properties of a file, with human readable format in date ordered format. So I can use alias followed by the name of the new command equal to the command I'd like that to alias to. And usually put it in quotes. So now whenever you run ls full, the command line will treat that as a new command. It will automatically expand it and run the full command for you. Within these aliases, you can also use environment variables and pipes, for example. So you can see, I have an alias here, which is quite complicated, that I've named WH. All it does is echo out information about my environment. So my username, the host name, what directory I'm in, the date, and information about the uptime of the computer that I'm on. You can also use command pipes within aliases. So here's another alias that will print out all of my processes that are running, all the results of the commands I've run, and then it will just sift through them. Those will all be sent to grep. It will just look for ones that have my username in them. So PS will list who the owner of the process is. So this will just pick out mine. Then I actually will grep that, pipe that again to grep again to remove any entries that contain grep, since I don't want to see those. That's what I'm actually running now. So this is a useful command that I can run just to see what I have running. Normally if you run PS by itself, it will only show you processes within your current shell. So you can find that, you can make up aliases that will save you a lot of time in typing. And you'll find them pretty useful. If you want to see what aliases are set, you can run the alias command all by itself. All right, moving on to shell initialization. So what happens when you actually log in the background? When you first log in, you start up your new bash shell command line interpreter. Everything about it, like its environment and configuration that's set up, that you can set, is set based on this correct configuration file. So it's found in your home directory, and it's a hidden file. It starts with a dot, so it's .bashrc. So here you can see an example of a bash file, a bash configuration file that you'd normally find on Sharcnet. Typically at Sharcnet, if you don't modify this, you'll just see from here up. So anything that starts with a hash is a comment. and you can see it just says that this is the bash RC. It will look in a standard place in the file system for system-wide settings. So you'll get settings for your shell that are set ahead of time by the administrators or the operating system distribution. After that, there's a line that says user-specific aliases and functions. And here you can specify other commands, variables, or aliases that you'd like to have set within your working environment. So for example, if I always use FFTW, I can load that module straight from this file. And then every time I log in, it will be in my environment. Likewise, if I want to use that PS command, I can put it here as an alias, and it will always be available to me. And likewise, you can set variable names, so workdir, for example. I can export that, and that will always be contained within my environment. So setting up in your bash RC, you can set up your modules, environment variables, aliases, and they'll persist between one session to the next. You can even do more complicated things with bash programming, like setting up case statements, which will only load certain modules on certain systems. There's an example of that in our help wiki FAQ if you'd like to look into that, if you're using multiple systems for doing your pre and post processing. All right, so to wrap up here, this is the last thing I'd like to show you is the idea of shell scripts. So a shell script is just a way to write your own command file that will execute commands one after another that you can run inside the command line. So it's pretty straightforward to make a shell script. All you have to do is make sure that this first line, this header, is there. And then you also have to make sure that you change the text file to be an executable file. So for example, let's say I've opened up Nano and I've created this file, script.x. If I cat it, you can see it has the first line, the header line. When the command line executes this text file, it will look there first to see what kind of script it is, and you'll know that this is a bash script. You can also write scripts in Perl, Python, any other number of high-level languages that the command line interpreter will recognize. So you can see in this script, all I've done is the first line just echoes this text. This is a script. The second line runs the who am I command, and the third line does another echo, and it just prints out the value of my home directory, environment variable. So now to run this, I would have to change it to be execute, so I can do that by using chmod. With the symbolic notation plus X, just means to change it to be an executable for myself. Now if I run the command, if I do /script.x, because if you run a command and it's not in your path, you need to specify the full path to it, either the absolute or relative path. In this case, I've used the relative path. So it's in my present directory, which is a dot, so I just need /, the name of the file. Then you can see after you run it, the command line interpreter just prints out the echo command, prints out my username, and then ends it with the value of my home directory expanded here. So in this way, you can write, complex scripts that will do things. If your simulation generates 100 files, and you'd like to post-process them, you can write another script that does the same action to every file in a directory, for example. And in this way, you can save yourself a lot of time by avoiding having to run the same command over and over. It also allows you to have a repository for complex command sequences that you may have done in the past that might not be in your history anymore. If you save it to a script file, you can always come back to it and read it later, modify it, use it for different purposes, and what have you. All right, well, that was quite a whirlwind. I apologize for going through so much material in such a hurry. I definitely recommend that if you go back, look at some of these concepts, and definitely Googling online, Googling for commands. If you're trying to do something, it's a good idea to try to do a web search to see if that command already exists within the operating system or the shell, and avoid writing really complicated scripts or commands. But hopefully this gives you an idea of the different possibilities and what you can do with the command line to make your work easier and more sophisticated.